All right, I'd like to go ahead and run through solutions for AP Physics linear motion. First problem, we're going to add four vectors, okay, that are described like this. And we're told that we should choose our frame of reference and coordinate axes carefully. So, taking a quick look at this. All right, so quick sketch of the axes. All right. And if I draw in my vectors, they tell me that the first one is making, let's see, an angle of 35 degrees above the horizontal to the right. So maybe that looks like this. And they tell me it's got a value of 12 newtons. And that's when they tell me it's 31 newtons to the left, 55 degrees above horizontal. And this angle is supposed to be 55 degrees. And they tell you 8.4 newtons left, 35 below. Well, if this is 35 above, 35 below, it's actually going to be collinear here. And this one is 8.4 to the left. So this one's shorter than that. And the fourth vector is to the right, 55 degrees below horizontal. Well, if this is 55 below and this is 55 above here, it's collinear with that. And so it's going to come down like this, and this one's 24 long. Okay. So the trick is, in solving this one, is you say, well, if I was just going to teach a computer to solve problems with adding vectors, I would just tell them, hey, take every vector, split into x and y components using cosine, right, the angle with the x-axis and sine and so on. Measure my angle from to the right every time. So for this guy, I would use 90 plus 35 be 125 degrees. And that way, when I do my cosine of 125, it'll make it negative for me, that x component. And sine 125, of course, will still be a positive. So always measuring my angle from here and just do cosine for the x components and sine for the y components, and just add them all up, all four x components, all four y components, make a new right triangle, yada, yada, yada. However, because of the way these happen to be collinear and these are collinear, and furthermore, if this is 35 degrees and this is 55 degrees, then combined, this makes 90. And so we can see that these guys are all at nice right angles like so, right? So it's actually like so slick in this particular problem that I can rotate my coordinate axes. So like I'm rotating the coordinate axes, 35 degrees this way. Then I'm just dealing with these arrows going left, right, up, down. So if I did that, if I take my coordinate axis and rotate counterclockwise 35 degrees, that's like basically subtracting 35 degrees from all of my angles, right? And rotating the diagram like this, rotating the axes this way, rotating the vectors this way. But that's going to turn this into so I'm like rotating my coordinate axis. I'm like changing my like frame of reference basically on the problem, rotating 35 degrees. Then I'm going to end up with just, look, 12 newtons to the right and 8.4 newtons to the left. And 31 newtons up and 24 newtons down. And you say, well, I can just really quickly then say 12 to the right, 8.4 to the left. That's just 3.6 to the right. And 31 newtons up and 24 newtons down, that's just 7 newtons up. And if I have these guys at right angles to each other, I can find the total of these vectors. I'm just going to add them tip to tail. So adding them tip to tail is going to be 3.6 newtons to the right and then where that one ends, the next one starts, 7 newtons up. So then, you see that's going to be my total. So I'm just going to use Pythagorean theorem. And with Pythagorean, I'm just going to get 7.87 newtons out, right? When I do my root of 3.6 squared plus 7 squared, right? To get this total, I'm sorry, this is a force, isn't it? Total force, right? Okay, so that's the magnitude of it, right? But I also want to give the direction. So you say, well, to find that angle, I'm going to use an inverse tangent of the opposite over the adjacent. So inverse tan of 7 over 3.6. And my calculator spits out an angle of 62.8 degrees. And you say, okay, my final answer, though, is not going to be 7.87 newtons at 62.8 degrees because, remember, I rotated my coordinate axis 35 degrees. I got to rotate it back, right? So this guy, it's really got to be, I basically shifted my vectors, like I rotated the axes this way, 35, I got to rotate them back 35. So it's like I subtracted 35 degrees from all my angles. I got to put the 35 back on. So I got to add 35 degrees. So I'm going to be at 97.8 degrees. So my final answer is going to be 7.87 newtons at 97.8 degrees.